Greetings and welcome to another episode of Alfredo's Code-Along Tutorials. In this one I've decided to make a chess engine, and I think it's a quite interesting project that covers everything from front-end UI to back-end algorithm. And well, let's just get into it. To start it off, we'll just make the user interface. I always like to make sure I have something to see to help me debug, as well as check out if all of my functions are working properly. And start it off, we will set up the space we need, which is a colored rectangle. Just make it simple, nothing too complicated. And we have it to fill, if I can remember how to do these. And let's have a different color that is not blinding me. Something like this will do, a good background. Okay, let's just call it background for housekeeping. Then we will make the chessboard part of it. My plan is to make two different types. Colored rectangle. It's kind of hard to speak and do this at the same time. Okay, so for this, I will be making it, actually, what is the project size? I think we'll be looking at something that is rendering. Nope, display, there we go. 648, let's do that. 648 and 648. Simple enough. And let's make this something of a slightly brighter color so we can separate two. My plan is to have the left side as a chessboard and right side as buttons or other sort of things you can type in interaction with. Okay, let's call it chessboard. Okay, to create the grids, I'm just going to use a grid inventory. A grid container. If you've seen my previous video, you will know about how to make this, and since I'm quite familiar with it, I'll just use this instead of an image or other ways. Okay, and let's see, we should make this 18 times 6 without how many blocks are there? 8 blocks? Yeah, so we do 8 times 640 48 45. Is that divisible by 8? I don't fully remember. Let's do 620. My math brain is not helping me that much. Alright, and let's center it with an anchor. I believe it is done. I don't have any idea how it's done. Isn't there an anchor somewhere for me to click? Ah, there we go. Lovely. And we will start filling this out with individual grids. And with that, I'll just make another colored rectangle. And choose the size to be, I believe this is, what did I calculate it as be? 78. Looking good. And we'll fill it up. Okay, a few things to change. I want it to be a column 8. And color rectangle, let's make it, what color are chessboards usually? Like something like this. Good enough. Alright. So, let's first see if it propagates properly. Looks good. Oh, don't forget to change the grid container separations to 0 so that they propagate seamlessly. Good. And now we attach a script to it. So this will be a mixed language tutorial. We'll be using the GD script for the GUIs and the display part, and using the C# for the calculation intense portion of the algorithm. All right. So, before I forget, I will be doing this. Let's make this an individual scene. Scene. Let's call it slot. Save branch of scene, save. And now we can go to open the scene ourselves. That, and let's give it a filter, which is another color rectangle. Call it the filter. Make sure it is. Oh, no. I want it to fill, and I want it to look transparent until I've changed it. Alright, let's go back to that. Also save the main GUI scene. Alright, before I forget, I'll also make a main scene, which we'll call it just main, I guess. And we'll add the GUI here. Oh, oops, that is not what I meant to do. There we go. So let's save the main, and let's run it real quick to make sure everything's going on properly. All right. I apologize if it's a little bit confusing to start with, since I really did not make a good script for this. All right, first let's propagate the slots. So we should call a new function, create slots. Is this how you spell create? Okay. And set a few things up for housekeeping. We'll start with a few references. For example, the slot scene we need to initialize, which we start with a preload. And find where we have this. Perfect. Not perfect. Better. Okay. Basically, to create a slot, we need to set it up. And instantiate it. And then we set up a few things. The attributes for the slots, or variables in the slot. So we create a quick slot scene, and let's call it slot ID. We'll need that to reference the slots. I think we'll just initialize those -1. And I don't think we need anything else at the moment. Now, dot slot ID. Is that what I name it? Yes. Is, and let's create a different container to save all the variables. Basically, if we want to fetch these slot scenes or slot instances, we'll be able to find them here. So basically, this gives them an increasing ID from 0 to however many we made them, and we will add it to the grid array. Push back, new slot. And then we should probably add it as a child so it shows up. I believe that will be done. Before that, let me rename this so I don't forget what it's called. And also give it a reference called the board grid. Lovely. Let's add the child first, just to be safe. Board grid dot add child. Okay, this looks good. And so in the ready function, let's make, well, a few of them. 64. Let's call create slots. Well, it should be create slot, since everyone creates only one of them. And let's see it. Does it fill it with the... It does. Now a chessboard has alternating blocks, so we should probably change that. Let's just make a quick function in here in the slot scene, or slot script, call it set color. Right. So, or set background? Set background. We want to input a color, and we don't really need it to return anything. Self color is this. Looks good, looks good. And then we can call it to change the color of, you know, the background. And now I think we'll do it here. To alternate it, let's use a quick temporary variable. Let's call it a 0. And then we loop columns and rows. Rows and columns? Columns and rows. So it is an 8x8 board. We will have this. Excuse my poorly chosen variable names. And this is where we detect if we have a, well, what color it should be. So if initially it is the same as, well, it's a even number, we want to set the grid array, well, the current grid array index, which is just column times the width, multiply the row, sorry, the row times width plus the column. And then we'll set the background into a different color, which is, let's just do color. There, good enough. Okay, and every time we finish this one loop or one row, we want to flip the bit because the starting color of each row is different. And you'll see what I mean real quick. Else color bit. It's probably a shorthand way to write this, but for simplicity and clarity's sake, we'll do it here. All right. Oh, color bit. Not bad. And this should give us a good looking chessboard. Lovely. Now let's put in the pieces. To do that, I think we'll create a quick piece scene. Let's call it, well, piece. Let's start with a 2D node and give it a texture rect as the icon. Texture rectangle and icon. It's so hard to type in the I. There we go. Okay, and let's go to the 2D view. So basically we want this to align somewhere. If I could find it real quick. Center. Okay. And we will, for example, I have a art asset folder ready with just a bunch of PNGs of the chess pieces. You can get a free one from itch. I'll include a link of the one I used in the description below. Okay, so basically what we want to do is to have one of the icon in there, and let's take a look how well that looks. That looks a bit too small, but I think we'll work with it. Okay, we also want a script to go along with it. And just have a few housekeeping variables. Save the path of the icon. And let's also add the slot ID for unknown purposes. Well, just to keep in check. And I also plan to use a variable to keep track of what type of a chess piece it is, which I'll just call it type. Simple enough. Okay. So to load the icon, we need a way to handle a lot of information. For example, the location, the path to the icons, as well as how I keep track of piece types. This is where I start a script. How do I make a new script again? New script. There we go. A data handler class. I love a data handler. That's in every one of my projects, I believe. Okay, and let's see what we need from here. We need a dictionary of assets. And basically we want to make sure every time we look for a piece, we can get the corresponding location of it. So before I propagate the dictionary, I will make a quick enum that has a collection of names for all the pieces. So to save you some time, I will quickly cut to when I finish this whole thing. Okay, so basically it is just an ordered list of, well, enum of all the variable names I plan to put in. It's the different pieces. We start with whites and go to blacks, and basically lines up with the icons. So what enums in Godot do is basically to have a human readable name replaced with a integer value starting from 0. You can customize it, but I'm just using the basic ones. And then we can use that value to find the corresponding assets in here. There's probably a better way to do it. I'm just doing the dumb way, so be right back. Okay. If you have more assets than just 12, I would recommend reading the directory and parse through the strings. But for me, this is probably suffice. And we have a collection of values that we can use in other places. Okay, so now we go back to our GUI and try to add one of those pieces. All right, let's start with a new function. Call it add piece. Easy enough. And we want the piece type to be entered. Don't really need it to return anything, so we'll just do that. Other than the piece type, well, let's just make sure it's called what I mean to call. And we want a location of the piece to tell us where to put it on the board. In that case, we will have a new piece that I should probably instantiate on ready. So piece scene, and let's give it a preload. Where did I put the scene piece? Oh, did I not save it yet? There we go. Put it in here. Lovely. And now let's go down here and keep our work. So let's do the same thing as slots. We instantiate it and we add it to the chessboard. Do I have a path to chessboard? I do not. Let's add it in there. Oops. On ready var chessboard. Looks good. Looks good. And we can add it as a child. add child. That is not how you call this function. There we go. And we also want to make sure we set the type as the piece type we sent in and we passed in. And we also want to set up an icon. So since we don't really know what the icon is yet, well, we know it by the piece type. We want to make a function in there called, say, load icon, and it will load the piece. Right, since we don't have it, let's go quickly make it. Let's go to the piece script and make a load icon function. Piece name. Right, this looks pretty good. Okay, so basically we want to change the texture. This is the, let's see, the icon texture. And use the data handler. Data handler. Oh, before I do that, I almost forgot to properly use data handler everywhere. We wanted to make a auto load. So let's do that. Add enabled. Good. So now this can be used. It will show up as a global class we can reference. Piece name. Okay, so basically this just fetches the value from data handler, which is the corresponding path for those icons. And this should do it. Let's do a quick test. But before that, we should probably give it a location. So basically the location of a piece will be referenced from the grids. So for now, there are individual grids that shows up here, and each of them will have a location linked to it. In that case, we can just find the location pretty easily by using the ID we created earlier. So let's set the global position to the location. Literally, we first find the location. Sorry, we first find the slots by using the location. Location is going to be an index. Probably add in the description a bit. At the comments, I really don't have good comments for this, or have it with comments, but I am working on improving it. We fetch the location. I think this will set it to the top left corner of the slot. So, well, let's first test it, I guess, before we think about the rest. Piece. Okay, we should probably, as I'd like to do, have a way to reference where all the things are. So let's keep it in a piece array. And then set up the attributes like we always do. Do I actually have those? Yes. And then we set the type. Type. Did we set up a type already? We did. Okay. So now that we have these, we can make a button to test out these things. Okay, so in this case, I'll just quickly make a button. It's the tester button. I'd like to just, doesn't matter what it does. Let's call it test button. Test button. It does, well, what it says, test. Just to make it a bit more pleasant to the eyes, let's make it slightly bigger, say 30. Good. Okay. And connect this to button pressed to a different function. So basically when this happens, let's say just add a piece. and we'll see how well it works. Okay, so piece type, we can use, once again, a handy data handler for its piece names. Piece names, call it, say, Black King. Right, this is the first argument. The second one will be the location. So say we want it on the 4th grid. And let's see how well it does. Not very well. Alright, let's see what we did wrong. Invalid set index 4 to the node to the... Oh, because we have not initialized this array. Common mistake from going from C languages to Godot's 3D script. So what we need to do is to fill out the array with, well, with zeros and make sure we initialize it. But since there's no real way to initialize this, we will just fill it or resize it and then fill it with zeros. I believe that will solve the problem. Let's give it a try, and yes, so currently it is snapped to the top left of the 4th grid, or 5th grid of index of 4. So in that case, we'll just add a quick offset, icon offset. All right, let's set that up as, I think, just gonna be half of the icon size, or sorry, the center of the slot, which I believe the slots have a size of 78, so half of that. Vector 2 of... I'm too lazy to actually calculate it. It's 34. No, it's 39, isn't it? Make sure to use my brain more often so it doesn't go dumb. Good. And I think that will do it. Let's give it a try. Lovely. Just so it fills the place, let's size it up a little bit more. Let's use a scale instead and say 1.5. Okay, does it make icon bigger? Probably. Now let's see if it looks better. Much better. I think that fills the slots a bit more. Okay, now that's done. We want to make sure the GUI understands if I want to set up a board a specific way. And the chess community has a very convenient way of doing it in terms of a FEN string. So if you don't know what that is, look that up. It basically is a long string that conveniently collapses all the chessboard into one single string. So I'll quickly look up the chess FEN string starting position. I should have this prepared, but I do not. So you have to stick with me for a bit longer. FEN string of the starting position. Very good. So we'll have that. And we will add a function to parse a FEN string that we put in. Let's see how we should approach it. All right. So instead of here, we'll make a new function called Parse FEN. And we want a FEN string to be added in. It also doesn't really return anything, so. All right. So let's call the board state, well, board state. All right, I'll go through what each part of the FEN string does so you understand what I really am doing, but you should probably look it up yourself. I'm not the best at explaining this. So the whole first part of the FEN string is currently what we're interested in, and each of these letters represent a piece. So for example, it's currently rook, knight, bishop, queen, yada yada. The slashes signifies a line change, and these numbers means how many vacant spaces are there, or there are. And I believe the capital letters are white pieces and the under or lower level lower cases, letters are black pieces. So we first split it into different pieces where we are currently only interested in the first portion of it. And then we'll have a index as a counter. And we probably just want an int for it. Okay, so board state. We are, as I said, I'm only interested in the first portion of the string, which is just this part of the string. Okay, if it is a dash, we don't really care about dashes as line changes for now. We just keep going. We just skip it. Continue. If I could spell continue, that'd be great. And let's check if it is a number. If it is number, it just skips a few empty spaces. Valid int, I believe, is the function. Yes. So we basically support index. We just increase it by however many i's we have, or however many number the I is. I is the individual characters in the string. So say we find 8, we just add the index or the counter up to 8. All right, now the rest of the occasions we will actually add pieces because we see letters. You might want to add in a failsafe if you don't, if the fen string is not a proper fen string, but I'm very lazy, and as long as it works, it works. I'm sure a brilliant person like you will probably improve it on top of it, so I do encourage you to improve on top of my system. Okay, there's something's wrong. Board index, did I spell it wrong? Index. I did. I know myself so well. Okay, so we call the add piece and use the corresponding letters. So basically we want to make sure we want to know what each piece represent, and we want to get back the proper index. Say white king, white knight, right? When we have K, N, etc. Meaning to get the piece type, we want to go back to the data handler and add in a new dictionary. Let's call it FEN dictionary. And what we'll include is just a bunch of, well, string pairs. So for example, the B is going to be black bishop, king is K as for black king, etc. And I will save you to wait. Editing magic. Okay, so we have a complete dictionary, and we'll be able to change the characters to put in into the corresponding enum, which is just an integer. So now we can just go back here and put in what we want. FEN dictionary. We put in the character, it should spit back the piece type. And then we want a location, which is just the index. That's why we kept the counter. Okay, so now this setup, let's actually call it. Instead of just adding one, we will add parse FEN and put in the FEN string. This is the starting board. Okay, so if everything goes right, we should have a complete starting board, and we did not. Why is that? Let's quickly debug the system. It is the fun part. Oh, simple. I think since everything is stacked to one slot, it is because we did not advance the board index. I think that will solve the problem. Let's take a look. Lovely. So now we have a beautiful starting board set up. Of course, it does nothing. There's no backend data. There's no user interactions. but it is now capable of taking a certain fence string and taking the fence string and put up the board. So it should be simple for a debug session. Okay, now let's try a different fence string. Is found a random one on the wiki, and let's see if it gives something different. It does, and it is correct. Very good. So I think this will be the end of the first episode. In the next episode, I think I'll tackle the C# part of the chess engine, and likely a lot more interactions, but I probably won't go into the algorithm or the AI part, the quote-unquote chess AI, until maybe the third or fourth episode. We'll see. All right, thanks for watching.